All right, last shape of the day, octahedral. A lot of transition metals adopt an octahedral type of complex. So with octahedral, we have six electron dense groups, and all of them are atoms. So it looks something like that. If you think about why it's called an octahedral, well, it's because it's got 8 faces. So there'd be one face, one in the back, one there, and then a fourth one there, and then 4 more down on the bottom. So it's called octa8 for 8 faces, but it only has 7 atoms and really only 6 electron dense areas. An example of this is Sf6 sulfur hexafluoride. And of course, we can draw it here. Let's get rid of all these lone pairs. There's 2 bonds, 3, 4, 5, 6. Right, boom, you can see octahedral there. In terms of the bond angles, all of the bond angles are 90 degrees. So this is a perfectly symmetrical molecule. So there is no equatorial and axial. They are all the same. And then we go through, right, taking away atoms and replacing them with lone pairs. So once we do that once, we get square pyramidal. And it makes sense, right? We've got a square right here, and then if you connect it to the top, it looks like a pyramid. So it's a pyramid with a square base, as is instead of before where we had a pyramid with a triangular base. Example of this is BRF5. And of course, you can take a look at it here, remove a bond, and note that it won't let you add more than 6 bonds because we don't have any shapes beyond there. Once you get beyond 6, you're just putting way too many electrons in too small of an area. Place one with a bond, boom, we've got our square pyramidal. Take away 2 atoms, replace them with lone pairs, you've got square planar. The example here is XeF4. Xenon again. Right, and that makes sense. We've got a flat square. Over there, boom, there's our square planar. We could have T-shaped as well, but these are relatively rare, so we're just going to go ahead and ignore them. So there are your shapes, know your bond angles. It's a bit of memorization, but if you think about the name of the shape, and if you logically try to put these atoms and think about the electron pairs repelling one another, it's all very logical.